Hi everyone, I'm Tobias. I've been working in the industry now for the past 20 years. Since last year, I'm the CTO at Arturia, leading there the engineering team. Arturia is located in France, in Grenoble, and we are building a variety of products, really from VSTs to sound cards to embedded systems, even full hardware synthesizers. But you might not guess it from the picture. I actually don't make music in my spare time. What I like to do is actually I like to build things, especially for VR with Unreal Engine. And lately I was working also more and more with coding agents, which then inspired this talk today. So over the past years, I was actually experimenting a lot with different kind of solutions and different kind of tools. And I ended up using RuCode, which I don't know if many of you know. It's an open source coding assistant plugin for VS Code, where you can design your own workflows and plug in your own models and try out different models. And beginning of this year, there was this mystery model released by OpenAI, which turned out to be just a previous preview version of GPT 4.1. And I used this opportunity because it was amazing. It came with 1 million token context window, huge. And at the same time, completely for free if you share your data. So, and you know, as an audio developer, I thought, okay, I need to build something with it. So first thing which came to my mind, okay, let's build another synthesizer. So not very creative, but I know how to do it. So I wanted to see how good the tool actually is. So what I've done here, you can see RuCode and VS Code. So I basically put all my requirements into a Markdown file, then turned this into an implementation plan and just let it go and see what it does. And the synth itself, here you can see the result. Okay, it's pretty basic, right? So you have an oscillator, a filter, an envelope. So not very exciting, but it actually made sound. So that was pretty cool. And actually, what was not so interesting for me was the synthesizer and the synthesizer code. I was pretty generic and I could have probably done it better. What actually really convinced me was the fact that I didn't have to hassle with CMake and with Conan. So I use Conan, and I never used it before as a package manager. So, and I mean, maybe I'm the only one. I hate CMake. So, and it did the job really, really great. And then also setting up the Git repo, doing all the Git handling, commit messages, amazing. This and the second thing, actually seeing for the first time this agentic loop in action was also very impressive, right? So it writes the code, it doesn't compile, it fixes it automatically, then it iterates, and eventually it works. So seeing this for the first time was actually pretty cool. So after the week, I really saw the potential, you know, that, okay, there could be something. But I also realized very, very quickly after the trial period was over that there's actually a very, very expensive approach. So you can spend a lot of money when you call the API and the tokens, especially when you have a huge context window. So I was actually pretty hesitant to use it. And I tried out different tools. I ended up actually with Copilot, was not 100% happy. That time they didn't have the agentic mode. Also, it felt very slow. Maybe it was because I only paid the $20 plan. I don't know. What really changed for me the whole game was when Anthropic before summer released Sonnet 4. And also they came up now with a new pricing scheme where you basically just start with $20, even though I ended up after 3 days in the max plan, so it's like and it also came with Claude Code. And when I tried it the first time, what really convinced me was the capabilities to break down bigger things into smaller chunks and being able to follow the plan. I did not see that with all the other tools I tried out before. And this is the result of it. So I got hooked, you could say. So this is my my personal Git account, contribution history. And so you can see in the dark squares there, I didn't get a lot of sleep over the summer trying out these tools. So maybe just a word, so agentic coding, what is it actually? So for me, it's really these three things, right? So you have LLM, you have the tools, and you have the control program. So the LLM is really let's say, the reasoning engine. So the model, and I mean, you can use GPT, Gemini, or Sonnet, whatever you want. Then there is quite some logic and power actually in the control program. So, being the ability to plan, break it down into to-dos, and then also manage all the iterations, right? And then what sets it apart from, regular chat solution is the capabilities, and then also being able to execute tools. So you can run your compiler, you can run the tests, and then you can react on the outputs. So on the right-hand side, you see just Claude Code as an example. I mean, there are many other tools out there, right? So Kodak, the OpenAI version, Cursor, IDE with this kind of functionality, Copilot, Client, OpenCode. I just put in here all the tools which have somehow the letter C in their name. So the whole space is really exploding. It's hard to really keep track of it. So, but what they all have in common besides the letter C, it's the autonomous execution. So really that the capability of making this kind of to-do plans, implement it, then build it, execute it, and depending on the result, then also being able to refine it. So it's super powerful when it works. So the problem is, in reality, it's just due to the nature also of LLMs, it doesn't work all the time. And you should be able to realize when it doesn't. And I just put in here a nice example. I hope you can read that. So I try to get just the date and try to write it into a file because I'm keeping track of the plans I'm creating. And I'm working here with Opus 4.1 in thinking mode, which is, when you look up the documentation, is the exceptional model for special reasoning tasks. I would say it failed in that instance. It's like, so it checks the date. September 18th looks very valid to me. But the agent says, okay, there's something wrong. September doesn't have 9 months, which technically there is some logic to that. Yeah, I could sign up for that. The problem is just the conclusions are completely wrong. So it's like, it's very confident, but it's just wrong. So, and I think when you work with this kind of LLMs, you need to be aware, and I mean, sooner or later you're gonna run into this kind of issues, into hallucinations, which you can see here. Context collapse. This is the phenomena when it totally forgets what it had for breakfast. Task drift, also something. So it starts to do something, and then it somehow does something completely different. And the last one, pretty annoying actually, mocking functionality. You think it implements it, and then you look at the code, and there's just mocked functionality. Maybe there's sometimes a to-do, but if you don't check it, and then you think, okay, you're done, but half of the functionality is actually not there. So if you're a Claude user, you might also recognize the other two things here. You're absolutely right. One of the favorite statements. This is actually when it took the wrong direction. It's just a polite way to express it. And yeah, let me try a simpler approach. Usually means it turned a lot of circles, and in the end, it just gave up. So it's throwing in the towel. So in that case, my advice: start from scratch. Don't continue with your conversation. So the question now, with all these problems, are the tools really worth it? And I think a quote which really, really well matches is, all models are wrong, some are useful, and this totally applies also to the AI tools, I think. So they're wrong all the time, they hallucinate, they forget, they give up, but I still think there's a lot of value in there, and the whole question is, what can we actually do to make these tools more useful? And I think a big part of that answer lies actually into how you manage your context. So, and to understand how to fix these kind of problems, I think it's important to understand or to have a mental model how these LLMs work. And what helped me really is to see this as pure functions. So it's like the LLMs, they don't have memory, they don't have state between the calls, so everything is managed actually around it. There is a small recursion because usually what you do, so you feed the tokens in, you get the tokens out, and the output ends up again in your context usually. And so you have this little recursion. So your quality of the output totally depends on what you put in. And there are a couple of things you should be aware, and you should avoid these 4 mistakes. So missing information is number 1. So when the model doesn't understand or doesn't know your architecture, it's going to make something up for sure. When it has the wrong information, so you had a long conversation going on and you changed your requirements, it might pick up on the wrong information. If you put in too much information, so you put in your whole code base, or you try to, into your context, then maybe it's hard to find the signal and the noise, right? So the needle in the haystack. Or another problem can be it just goes off in the wrong direction, going down the rabbit hole and completely goes off track, right? So you should try to avoid this situation and manage your context properly. One thing also important to understand is usually the LLMs, they have a lot of great general knowledge, right? They know how to code C++, they know how to work with certain algorithms, they have the design patterns and so on. What they don't know is the specifics of your project, right? So, and all the specifics you need to put into your context. So, this is probably how most of us has started to use these kind of tools, right? The chat approach, using it like ChatGPT. So I start a conversation. I say, okay, just add this feature or fix this bug. Then going on a long thread, then do something else. That at some point in time, you run out of context and auto compact kicks in, and then you continue and continue. That actually works quite well for smaller tasks, but the problem is it doesn't scale that well because usually over time, the quality of your context degrades. And this means also the quality of your results degrade. And eventually you're going to end up in a situation where Claude tells you, okay, let me try a simpler approach. And then you know you are at the wrong end. So you try to avoid this kind of situation where your context collapses. And there are simple things you can actually do, which helps just to basically have better conversations with your coding agent. One is to watch your context percentage, so how much you actually use your context. To be honest, I still don't understand why in Claude there is not an automatic possibility, or why it's not per default that you see actually how much context you're using. But there are ways actually to modify your status bar so that you can see that all the time. So that's super, super helpful. I personally try to stay below 50%, so never hit more than 50% or even the state where you need to compact. And you just can try to avoid this by, when you're reaching that point, trying to do manual handovers, right? So try to really to say, okay, all the conversation we had so far, please document all the key decisions. What's the current state, the next steps you need to do, and then you start a new session and start from scratch with this type of information, right? So you should reset early and reset often. And to be honest, that also helped me to use better Claude and ChatGPT itself, because I was totally messing up my context when my conversations got too long. So that can be also helpful in that type of scenario. So, but there is actually one approach I would like to show is a more structured approach. A guy named Dex Hordy, he has a very good talk on advanced context engineering. I put here the link, so he has all the slides up on GitHub. So he calls it frequent intentional compaction, which is basically the idea, instead of having a long conversation, you break down your development workflow into phases, into research, planning, implementation. And after each phase, you document your current state, put it in a document, reset your context, and start fresh the next phase. That works really, really well from my experience, and you don't run anymore in the situation where you eat up all your context window. So how does this work in practice? Basically, you can even download all the comments and the whole Claude setup from his GitHub. But basically, you have a couple of slash commands, one for research the code base, which basically, when you want to start a new feature, you're going to try to figure out where do you need to implement this. Do I have all the documentation? So it also spawns a web search potentially. And then it puts everything into a research document, which you're going to review to see, okay, is all the information correct? You can directly hand this then over into a new session to the next command, which is create plan, which then really identifies the individual lines it needs to change. So it's a very, very detailed plan. And then you can also review the plan, start a new session, and then you just implement it. And you're going to see that the implementation goes then very quick because all the preparation work is pretty much done. And by this, you save a lot of context then in the implementation step itself. There's also a command where you can then also validate the plan, because in the plan you have then basically checkboxes, and every time it does something or it achieves the step, it also basically checks the step. But just to make sure that it didn't forget anything, you can basically double check it and do a code review. So this type of framework, super, super helpful. Just to give you an idea, I basically adopted then for myself. I just took the source from GitHub and implement my own kind of system using slash commands, subagent, and skills, the new feature. And maybe two things really to point out, because I'm not going to go to all the details. When you set something up for yourself, the best thing you can do is actually ask Claude or your coding agent to help you with this. So you're saying, okay, I want to implement this kind of project. This is the workflows I would like to achieve. I would like to have code review or this kind of testing capabilities. And then ask it, okay, how do I do this with slash commands and subagent? And it figures it really out how to do it, because I was always asking, okay, myself, is it now a slash command, or should I put this more into a subagent, or is it a skill? So in that sense, it's super, super helpful that you can actually do kind of meta programming in that sense. So Claude helps you to set up your whole development environment. The other thing I would like to mention is, because I had a discussion actually with Thiago about code reviews, because there is something which is called LLM as a judge. I'm not sure if you heard about that, but LLMs are surprisingly good in reviewing their own code. So usually the code quality itself is not that great when you write it in the first attempt. But what I usually do is once or twice go over it and let it review itself and implement all the changes. It works surprisingly well, and you end up with a way higher code quality than just doing it in one shot. So that's really something to figure out. So I have my own code review agent and my own command to do this. And yeah, maybe just one last command here on that slide. So all the project-specific stuff, like, okay, how is my plugin architecture, the audio coding standards? This is what you usually put in the skills so that the agent can then pick it up. So I wanted to show one workflow, and I apologize for the video quality. So something I couldn't figure out yet, how to cut videos with Claude Code. I'm sure there's some MCP client also for that. So I just tried to explain it. So this is what we are using at Arturia to also debug embedded systems. So when you have an issue in an embedded system, basically run a remote debugger, and Claude Code has the capabilities to connect to GDB if you're running it in a dedicated Tmax session. So you see, going to start actually the binary of Astrolab, and we hit a SIG abort. And then we just ask, okay, can you connect to the TMAC session, so to the terminal who's running GDB, and figure out what's going on? And the impressive part is, so you can basically, it figures out the whole call stack, the whole state of the application, and can quickly, because it also has the source code, figure out what the problem is, why we run into this sick abort. So in that sense, there was a assertion triggered because we called the voice manager with 32 voices, even though we only have 16 allocated. Too bad. So one last thing I want to show, because it's quite interesting what people build on top of this coding agent, especially for more complex projects. So there's a very sophisticated framework which I found super, super fascinating. It's called BMAT. It's a BMAT method. And it's a specialized multi-agent framework. That means like there are different type of agents for different type of tasks and roles. It's basically a small agile team built on top of Cloud Code with sub-agent. So I'm not sure if you can see this on the right-hand side. When you install it in your project and you start it, so then you basically take certain roles. You say, okay, now I'm the business analyst, and then you can do product briefs, PRDs. Then you hand it over to the architect to turn this into an architecture document. Then you have a scrum master who does the sprint planning. You break it down into epics, into stories. Every story needs to be reviewed by the tester. So there is a very, very sophisticated workflow. I try to sketch it out here, and you see maybe also the different roles. It's super interesting. And they're working on a new version where you also can scale it up and down, because the problem I had is when you have smaller tasks, it's a bit of an overkill to go through this whole process. But now they have different kind of level of complexity, and you can adopt then your workflow and build even your own workflow for that. So super fascinating. Not going to do into detail, but I just wanted to mention it, that also these kind of things assist. And actually, we are using this in product management at Arturia. So to write product requirements documents, doing competitive analysis, all of that is also included. Very interesting. So 2 more slides to finish the talk. I'm asking myself, where are we on the scale? And to be honest, is a pretty good representation of my personal journey. So when in April I was using RuCode, I was really thinking, okay, that's going to change everything. And then quickly realized, okay, there are some caveats to it when you're using it. So it's really, the tools are not so easy to use to get the right quality out of it. It's can be challenging when you're using it also for complex code bases, the confidence, the confusion, all these problems. So I hope that I'm already through the valley of disillusion, and I'm climbing slowly now up the slope of enlightenment. So yeah, I think it's a relatively new technology, and I think we all need to learn how to use these kind of tools. I see a lot of potential there, but I'm pretty sure we haven't reached the plateau of productivity yet. So, and all the research I'm reading is like, okay, individual developers feel more productive using coding agents, but when you look at the organizational level, the gains are not there yet. And there are different kind of reasons for that, right? So there's a lot of, we need to figure out around the whole infrastructure, right? How do we review all of that code? If you write so much with coding agent, how do you have you built infrastructure in place? How to benchmark it? If someone has a good way of benchmarking kind of coding agents, let me know. I would be very interested in that. And yeah, I think there's a lot to figure out on that. So, and I also want to close with one thing, because beyond all these kind of practical challenges, I think there's also a question, how does development are going to change in the future? So I think a lot of us love really the craft, the problem solving, the flow, just the enjoyment of creating code. And how does it change now, or does it change in the end, right? So are we just going to write specifications and orchestrate agents in the future? I don't know. I hope not. My personal take on this is I really love coding. I really love development. And for me, I really see the benefit of using these kind of tools and spending more time on what I actually want to do and less time what I don't want to do. So dealing with CMake, writing unit tests, all these kind of things. And also what I realize is I'm doing totally new things which I haven't done before, because the barrier for entry for learning a new technology or learning a new framework is super low, and I really enjoy it to try out new things. So for me, it's a big boost of creativity. It can be very frustrating sometimes, but it's also a lot of fun. And that's all I have. Thank you.